So we're going to start on talking about 1.2 today. So it's on worksheet 3, but just a quick review, find the domain and range of this function. If this is the entire function, ooh, I just noticed there's a third piece. I'm blind. Does everybody see that there's a little piece over here too? Yeah, you're smarter than me. I didn't see that. Okay. So the domain, anybody? Yeah, it's left to right. So coming to the right, and then it looks like that's a -6, right? Yeah. And then your x values between here and here. 0 and 4, both with parentheses. Good job. And then over here, I would assume that's supposed to be 7. And it has a solid, so... Okay. Range I'm a little more worried about because students get confused. Okay. The bottom is -8. Do I need more? This goes up. So the bottommost point is at -8, and there is no topmost point. We don't need to describe all the rest of this because we're just looking for the very bottom to the very top. Good call. Okay. So today we're going to talk about a little more domain and range, and then we're going to talk about determining if a function is continuous. And this slide is wrong because we are actually doing this as well today. We're talking about even and odd functions and symmetry with the x-axis, y-axis, or origin. Okay, by looking at the graph of a function, you can determine the domain and range. We talked about this. As sometimes from the equation, we can also determine the restrictions. The x-intercepts of a graph are also called the zeros. We did that in the calculator, right? Some finding of zeros. Right? When you put those in the function, they should come out 0. Remember, the y-intercept is when x equals 0. Okay? So for this example, you have this on your sheet, but it says use the graph to find the domain and range and approximate the y-intercept in the zeros. So domain and range, domain because it's going wider and wider would be, yep, it's the way we write it, okay? And the range, yes. This point is labeled, and it's bottom to top, and it's y values. So, yep, 5 point, is it 0625? I can't see that. Okay. Then it asks for us to approximate the y-intercept. Anybody want to put a guess on that y-intercept right there? It's a little bit lower than that, right? 1, 2, 3, 4, 4.5. Is our estimate of the y-intercept, okay? And estimating the x-intercept? Anybody? -3, and 1.50 is what we're thinking? Okay. Then it says, then confirm algebraically. So I wouldn't worry. We could algebraically find the maximum point. Do you remember how to do that algebraically? X equals -b over 2a, and then plug it back in to find the y, right? Ew, doesn't sound that fun. The y-intercept is when x equals 0. So if we put a 0 back into this crazy function they gave us over here, we'd have 0 squared minus 0 plus 4.5. So we did really well on estimating that one. How do you find the x-intercepts algebraically? Y equals 0. So we would have to solve the whole thing. So what they did, if they set this equal to 0, they took out a -1. And then you had x squared plus 1.5x plus 4.5, which is still really gross. But they factored it here for us, okay, and got -3 and 1.5, so we were right on target. You could have also used quadratic formula. All right, so we have this one. It isn't done for us. Estimate the domain and range. Anybody? Domain is -infinity to infinity because it's going left and right. Seems good. Range. Yeah, same, right? It's going up and down forever with the arrows aimed the way they are. Okay, estimate the y-intercept. What do you think that point is down there? Careful, they're counting by 2's on that axis, aren't they? -2, -4, -6, -8. Okay, and then the x-intercepts only has 1, right? Or does it look like it's crossing the x at? Okay. Now, they want us to confirm algebraically. This is the algebraic expression, if I can read it. 4 cubed roots of x minus 1 minus 4. Right? Okay. So the y-intercept is just we put in a 0. 4 cubed roots of -1 minus 4 equals what? Can we cube root -1? Cube root, not square root. The cube root of -1 would just be -1. So then we have 4 times -1, should be -4, minus 4 more would be, is that what we had? Okay. Now, 2, 0 is setting this thing equal to 0. A little more complicated. 4 cubed roots of x minus 1 minus 4 equals 0. What could we do first algebraically? Add the 4 over to the other side. Divide by this 4 out here. We'd have the cubed root of x minus 1 equals 1. Then what do you do to get rid of a cubed root? Cube both sides. There we go. So we'd have x minus 1 equals still just 1, yes? Plus 1 would be 2. So we were right on with that one. Yeah, that one wasn't too bad. Okay. Now, this one, little not so good. Okay. Use the graph of the function shown below to estimate f of -2.5. This is on the quiz. Okay. Estimating from a graph. And actually on the quiz, I don't even give you a formula. I just give you a picture and tell you to estimate from the graph. You don't have to do any checking. But if we put in -2.5, this is an x value. Does everybody get that? So it wants to know the y value that goes with that. So if I go over here to -2.5, what y value you want to call that? 12? Does that seem okay? 12 or 11? I don't know. It's hard to tell. Okay. F of 1 would be when x is 1. What y do you think that is? Okay. And f of 7, when x is 7, what y do you think that is? Okay. Now, the equation is 2 absolute value of x minus 3 plus 1. If I put in a -2.5, stick with me here because some of you have trouble with this. What do you do first? Some people make it all positive, and it actually wouldn't hurt on this one, but you're not supposed to. You're supposed to do what's in there first, which would be -5.5. Then the absolute value makes it positive 5.5. So what's 2 5.5s plus 1? 2 5.5s would be 11 plus 1 is 12, so that was working. The second one, if we put in a 1 here, we'd have 2 absolute value of 1 minus 3 plus 1. This is where students get it wrong because they somehow make that 4. It's 1 minus 3 is negative 2, and then the absolute value makes it positive 2, right? So it's 2 times 2 plus 1. Is that one checking out okay? Okay. 7 we're supposed to put in. 2 times 7 minus 3 plus 1. What would that be? It would be 9. So this does not confirm algebraically. I really can't figure out what they did wrong on this graph. I think this branch over here is just supposed to be a little bit steeper. It should be going up 2 boxes and over 1. Oh, up 2 over 1, up 2 over 1. Yeah, they got off a little bit in here somehow. So their graph is not, this should be 9. Yeah. It's just trying to show you that if you can check algebraically, you should. On the quiz, like I said, the one that I gave you like this, you don't even have to check because there's no equation. I just said look at the graph and estimate these values. Okay? Do this for me because this is the one everybody gets wrong. What is f of 0? Yeah, it looks like 7, right? Because f of 0 means put in 0 for x, which means you go neither left nor right. You just go up to 7. Everybody good? That's the one everybody gets wrong. All right. Domain and range. Do you have these? This should go really fast. Do we need to do all these? Maybe no. Which ones should we do? Maybe the first and last? Okay. What's the first one? Be careful. Watch the scale. We're going left to right. -4 to 3, it looks like. Because this is -4 and this is 2 and it's between 2 and 3, okay? That's the domain. The range. -6 is the bottom. Top, it looks like 5 maybe. That one's hard to tell. Okay? As long as there's no open circles, though, you shouldn't have any parentheses, okay? Do you need me to do 4? What about 5? Left to right. No. -infinity, and then it's undefined at the y-axis, which would be 0. And then it seems to pick up again to the right, so 0 to infinity. This one is best done by looking at that equation right there. Can you tell the only thing x can't be is 0? Because you're not allowed to divide by 0. Okay, the range. Well, if you can't divide by 0, what you can't get out is a 0. So it's the same thing. It's okay if I skip 4? Left to right would be all real numbers till 4 for their domain, right? The range would be -infinity up to 3. All right, this is the meat of the lesson today. The new stuff. I'm hoping you talked about this last year, but I don't know how well you got this. Graphs of relations can have 2 different types of symmetry. Graphs with line symmetry can be folded along the line so the 2 halves match up. Graphs with point symmetry can be rotated 180 and appear unchanged. Okay? Those are the words you used in geometry. Does that sound familiar? Line symmetry, if you could fold it in half, some way on some line, and point symmetry if you could rotate it 180. All right? So we're going to talk about algebraically tests for symmetry. So the graph of a relation is symmetric to the x-axis. Now, is this a function if it's symmetric to the x-axis? No, because it folds up and down across the x-axis. It would match up to itself. To test that, it means you replace y with an opposite of y and see if you get out the same thing you started with. In other words, the same value should be true if y is 7 or negative 7, or 1y or negative 1y. The second one talks about y-axis symmetry. Now, is this a function? Yes. Okay. If it folds across the y-axis, so this is your line of symmetry, then it is a function, most likely. Well, it would have to be. I suppose there could be a vertical piece on one side or the other. So normally it's a function. To test this, you replace an x with an opposite of x. So you put in a 1x and a negative 1x, and you see if you get out the same answer. And then the weird one, this is symmetric with respect to the origin. So this is like point symmetry. It means you could turn your paper 180 degrees and it'll look exactly the same. Okay, so remember that. Point symmetry or origin symmetry is like turn it 180 degrees and it should look the same. Flip it upside down. It should look the same. Okay, so this one, you replace x with the opposite of x, and at the same time you replace y with the opposite of y to check, and then it has to be the same after you've done both of those things. Now we have a place to write this in just a second. This says that if it is a function, okay, it is called an even function if it has y-axis symmetry. A function is called an odd function if it's symmetric to the origin. Okay? So, you have this. Let's go through and fill this in. It says functions that have symmetric with respect to the y-axis are even functions. Okay? Y-axis symmetry, if it's a function, it's called even. Now, can we draw a couple on there? What would that look like? Okay, a generic parabola would work, right? That went through the origin. Is every parabola going to be even? No, it's got to have y-axis symmetry. Another one that is the sine function. Do you remember the curve looked like this when you did that in Algebra 2? You could have a goofy graph that was like doing this. As long as it is symmetric on both sides of the y-axis. Mine don't look perfect, but I'm trying. Okay. X-axis symmetry. X-axis symmetry, is it a function? No, if it has x-axis symmetry, it's not a function at all. But can we still draw some things that would have x-axis symmetry? Sideways parabola would work. Something else, right? Absolute value graph or something. Okay. Origin symmetry, okay, is where you replace both the x and y with their opposites, and it should get back to what you started with. It means you could turn it 180 and it'll look the same as long as the point you're turning it around is the origin. Okay? It's got to go through the origin or be around the origin or something. This is called an odd function. I just remember odd goes with origin. Okay? And I remember even goes with y-axis because it's not even a function. It's an even function. If it's got x-axis symmetry, then it's not even a function. Y-axis symmetry would still be a function, so it's called even. All right, something that has origin symmetry might look like this. Okay, if it's, my lumps should be the same size there. Something else, it could come through like this. it could also do this. It doesn't have to go through the origin. Yeah, it does. Everybody okay? All right, so analyze this graph to determine whether the function is even, odd, or neither, and then confirm algebraically, and this is the thing students struggle with. If it's odd or even, describe the symmetry of the graph. So I have to start with the symmetry. I don't look at it as even or odd till I figured out if it's symmetric. Is this symmetric somewhere? It looks like to what? The origin? Which would make it what? Okay, so we think it's odd. Now, here was the original function. This is already kind of done for you, so just pay attention, but was negative x cubed plus 2x. The rule for odd is that you're replacing both sides, both the x and the y, with the negative. Well, this was really y. So if we replace this, we'd get the opposite of y equals, now this negative came with it. We're supposed to place that with a negative 1x, and this one with a negative 1x. Okay, that's kind of messy. But what would happen back here? That would just be a minus 2x. Everybody okay? Or negative 2x. What is negative 1 to the third power? Negative 1. And an x to the third is just negative 1. So we'd have negative 1x cubed. But there's still what out front there? An opposite, yeah. So if I take that and leave this negative would become positive. X cubed. And back here, plus and minus 2x would be a negative 2x or minus 2x. Now, how could I get that back to y that I started with? Yeah, divide everything by negative 1. And I'd get y equals negative 1x cubed plus 2x. Is that what we started with? Way up here. So this confirms it, okay? And I showed my work over here. Students have trouble with that. Honestly, don't think you don't have to do it on the quiz. You just have to identify if it's even or odd and the kind of symmetry that means. Okay. Graph each function, analyze the graph to determine whether it's even, odd, or neither, confirm algebraically. If odd or even, describe the symmetry. Okay, so the first one is 4x cubed plus 1. Is that what it was, guys? Oops, plus. I typed minus. Okay, so here's, let's try a zoom standard. Okay, that's what I got. What are you thinking? Any symmetry? Origin? Okay, right now it's crossing up here, right? At 1. Look at my handy dandy picture. If I turn it 180, is it the same? No. Yeah, so this is, it's got no symmetry, so does that make it even, odd, or neither? It is a function, but it has no symmetry. Yes. Perfect. It could be even still, depends on the function. I would just graph it and look for sure, yeah. Number 7. X to the 4th minus 10x squared plus 9. Okay. X to the 4th. Then it was minus 10x squared. And then what? Plus 9? Thanks. All right, I don't know that this window's going to... Oh, it's not a horrible window. I could move my window down just a little bit so I'm sure it's not doing anything too crazy down at the bottom. Well, I'm looking at pretty much the whole thing here, and it looks okay to me to have what kind of symmetry? Okay, y-axis symmetry, right? It's flipped right across the y-axis, which does make it what kind of a function? Even. Okay, so y-axis symmetry, which makes it an even function. Okay, how do we test that? Y-axis symmetry is you change the x, okay? So we're going to go through and change only the x. So it'll say g of x equals the opposite of x to the 4th power minus 10 times the opposite of x squared plus 9. I ran myself out of room here. Okay. Well, what is negative 1 to the 4th power? Positive 1. This had a negative 10 out front. What is negative 1x squared, or negative 1 squared is positive 1, and then it's still squared. Okay, so when I was all done, I had an x to the 4th minus 10 x squared plus 9. It went back to what it started with, right? Okay, so that's the test. I'm sorry, that is so messy. All right, number 8. Anybody graph that bad boy yet? I think it's a volcano. That's what I call a volcano. 5x to the 4th. Oh, it's 5 over x to the 4th. I just forgot to divide. Oh, good. I put the divide on the wrong line. Try again. Does it look like that? If I go back to a Zoom standard. Okay. So, what do you think? Y-axis symmetry again, which makes it an even function. And the test would just be to put in negative x, and a negative 1 to the 4th becomes positive 1. So we're back where we started. Everybody okay with that one? Yes. Did you have a question? No. Okay. So number 9. Okay. X cubed minus 6x. Is that what it said? X to the 3rd minus, oops. I always forget to do that. Arrow to the right. Minus 6x. Okay. Ooh, that's kind of pretty, but definitely is not y-axis symmetry. It does look like a function. Does it look the same if you flip it over? Same exact shape, right? So origin symmetry makes it an odd function as long as, what do we have to replace on this one? Yes, both the x. So this was a y over here, and now it's going to become the opposite of y. This one is going to be negative 1x cubed minus 6 times negative 1x. Okay. Negative 1 to the 3rd is still negative 1. Negative times the negative back here is plus 6x. Why is that not back to what we started with? Yeah, because we got to divide everything by negative 1 to get y back to what we started with. Now once the y is back, this is actually all back to what we started with as well. All right, so what you need tied in your head together is that even means y-axis, odd means origin. Okay, what are you thinking? This one looks like origin, which is odd function, and it was y equals negative 2 over x. If we replace them both, we get the opposite of y equals negative 2 over negative x. That's a lot of negatives. If we divide those out, then if we divide both sides by negative 1 or multiply by negative 1, then this becomes, which is what we started with. Number 11 has some stars. I think it has stars because it looks symmetric there, but I kind of remember typing it in and it doesn't really look like that. Can someone read that one to me? Negative point. Sorry, negative 0.5 x to the 5th, arrow to the right, minus 3, plain old 3. Oh. I don't think their graph is
slightly off.
Yeah, I don't even know how. I don't think you could make a window that would make it look like that. Okay, so the graph looked even, or y-axis symmetric, but they totally were, wrong when they.
Was that just like a screenshot from the book though?
Yes, yeah. Was it? I forgot what it looked like. Here, let me just do this. Okay. Whoops. It looked like this when we did it correctly. Do we think it was odd? No, because when we flip it over, that intercept down there of negative 3 became positive 3 or 5 or whatever it was. So, none? I think I actually noticed it because I was like, it's a degree 5. That is not a degree 5. We get into that soon, but you remember that degree can predict the end behavior? It's a degree 5. The ends should be going opposite ways. Okay. Oh, that's it? Well, that was not hard. Okay, I made it. So, the bookwork is here. And there's nothing special about what's assigned. And the answers are okay, I'll post the PDF of the bookwork as well as the answers, okay? Are already posted. But that's it. Be working on this because tomorrow we're going to cover one more concept of continuity. We're going to talk about end behavior, but the quiz on Thursday has this on it. So make sure this is the last assignment for the homework check.